All right, here we go. Try this video again. Maybe we can get through it this time without being interrupted. A little bitter, a little grumpy. All right, so example 1 is asking us to start by graphing the equation. We can't graph the equation until we solve for y and get it into that slope-intercept form first. So to get y by itself, I'm going to start by subtracting 56 to both sides to get 8y is equal to negative 6x minus 56. Finish that off by dividing each side by 8. I could reduce 6 over 8. You can put that in your calculator. Let's just do that real quick since I've already wasted all this time. So 6 divided by 8, enter, math, frac, gives me that fraction of 3/4, and I just know to keep the negative. And negative 56 divided by 8 is negative 7. So I know that I'm going to start when I'm looking at this graph. You could either graph it by hand or you could go to your graphing calculator and go ahead and plug that in. Remember your fractions, you're hitting y equals to get to this y thing. Your fractions should be in parentheses. The X button you want to use is the one next to the alpha key. And then just minus that 7. So go ahead and hit graph and you'll get a visual of what your graph should look like. That makes sense that it's going down, that it has a negative slope because the slope here was that slope was equal to negative 3/4. So it makes sense that I'm going to end up with a line that's going in a downward direction. If you wanted to just plot some points, you could hit second and then graph again to get to your table, and you would just plot some of these whole number points. Negative 8 and negative 1 I could plot, so negative 1, 2, 3, 4, 5, 6, 7, 8, and negative 1. So you can continue plotting those whole number points. Or you could just use the equation. If I'm using the equation, that y-intercept, that b value, is telling me that I start at a negative 7. So down 1, 2, 3, 4, 5, 6, 7, because I'm on the y-axis, because that's a y-intercept. And then my slope tells me my slope is a rise over that run. So the negative 3 would be telling me to go down 1, 2, 3. And the positive 4 would be over to the right, 1, 2, 3, 4. And then to go in the other way, to finish that line that I've got there, I go the opposite of that. Instead of going down 3, I'm going to go up 1, 2, 3, and then to the left, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4, and there we have it. Shoot, that was a terrible line. I'll try this again. And then I'm just going to label it with the equation, negative 3/4 x minus 7. And there we have our graph. Make sure you're using a ruler or a straight edge of some sort, a book, your phone, anything to kind of make that line straight. So now part C is asking us about the intercepts. So we know that our y-intercept, that one we already talked about, our y-intercept is a negative 7. So my y-intercept is right here. And that would be an x value of 0, comma, negative 7 for the y value. But we still need to get our x-intercept. We know that the x-intercept is going to have a y value of 0 because we're not moving up and down at all. So we can do that algebraically over here in the corner. We are going to solve to find the x-intercept. We know that y, that's the end of first period, we know that y is equal to 0, and then we're going to find x. So if I go back to my equation, y equals negative 3/4 x minus 7. I'm plugging in 0 for y, and then just solving for x. Start by adding that 7 over. And then remember, getting rid of that fraction next to my variable, I'm just multiplying by the reciprocal. -4/3, and this is where I can jump to my calculator. Parentheses, -4 divided by 3 times 7 is equal to ugly repeating decimals, so I want to keep that as a fraction, -28/3. So x is equal to -28/3. So I never would have been able to guess that from looking at the graph. You know, that -28/3, that's a decimal, that's a repeating ugly decimal. I would have never been able to figure that out just by looking at the graph. I would have had to do some solving. So -28/3 is what gets filled in for our x-intercept. And now, last but not least here, this part D is asking us if this point falls on the line. You have two options here. Let's do this one in blue. So for D, you have two options. Option 1 is use the calc. Just go to that calculator, go to the second table, and look for that point. Look for -32/17. Takes a little bit of scrolling, but hey, especially if you don't like to do too much math, you know? All right, so there's -32/17 right there showing up in my table. So that leads me to conclude that yes, it does fall on the line. Or option 2 is plug it into the equation. If I had that equation that we started off with, that y equals -3/4 x minus 7, and I plug in, remember 32 is an x value, 17 is a y value, so 17 is equal to -3/4 times -32 minus 7. And again, I can jump right to the calculator. You're late for a second period. So -3 divided 4, remember I'm putting that fraction in parentheses, times the -32 gives me 24 minus the 7 gives me 17. So 17 is equal to 17 is a true statement, which means yes, the point is on the line. The point, let's be specific, the point -32, 17 is on the line. All right, so use your calculator to help you out. You've got that app on your Chromebooks that you could use if you don't have an actual real life calculator.